In this video, we're going to be learning about operation with matrices. Let's start by defining what is a matrix, right? So my first thing that I want to go over is that a matrix is a rectangular array of values. Usually, it's really like this, right? Something similar to what we have here on the right, right? The dimensions of a matrix are given in the form of rows by columns, written in as R times C. So rows is how many rows we have going down. So that means that we have 1, 2, and 3. And then columns is going sideways. So I got 1 and 2. So that means that this matrix here is a 3 by 2. A capital letter is used to refer to the entire matrix. So for example, this matrix is matrix A. A specific element can be referred to using subscripts to indicate the row and column where the element is located. For example, in matrix A, element 2, 1, so that means that is the number that is in position in row 2, column 1. So row 2, so 1 and 2, and then column 1 is negative 2, negative 2. And then the 8 down here is in row 1, 2, and 3, then column 2, so that means that this one is A, 3, 2. Next definition, equal matrices. Equal matrices have the same dimension. That's important, that has the same dimension, and corresponding elements are equal. So they have to have the same dimension. So on the case down here, this is a 2 by 2, and then a 2 by 2, right? It has two rows and 2 columns. So it means that to those two matrices be the same, that means that its corresponding value has to be the same. So for example, y is 7. And then we know that z plus 4 equals 5, right? Because it's an element at position at row 1, column 2, row 1, column 2. So that means that z has to equal to 1. And then 2x to find x, so 2x equals 12. So divided by 2, x equals 2, 6. Next type of operation is called scalar multiplication, and is the multiplication of each element in the matrix by a single real number called scalar. So in this case, is in a way to see it, distributing, right? We're multiplying the 2 times everything on the matrix. So 2 times 3, 2 times 9, 2 times negative 1, 2 times negative 2, 2 times 0, 2 times 2. Okay? So simplify. Start with this one here. So again, I'm going to start by multiplying the 3 times everything here. So that means that I got 3 times negative 4, 3 times negative 4, negative 3 times negative 4, negative 3 times 0, then we have negative 3 times 6, negative 3 times 2, negative 3 times negative 3. And so in that case, I have 12, 12, 0, negative 18, 6, and 9. 6 and 9. And that is my matrix. Okay, so the next one, again, we're multiplying the 2 times everything. So 2 times negative 4, 2 times negative 2, 2 times negative 5, 2 times 3, 2 times negative 5, and then 2 times negative 2. And that's going to give me negative 8, negative 4, negative 10, 6, negative 10, and negative 4. See, our next operation is to add or subtract matrices. The dimensions have to be exactly the same. So that's important, that they have to be exactly the same. 3 by 2, 3 by 2. It cannot be anything else that is exactly the same. Right? Have to be exactly. Then you add corresponding elements or subtract corresponding elements. So let's see this one here. Let's see number 1, right? Let's start by defining what are my dimensions. So this is a 2 by 2. This is a 2 by 2. So that means that we are able to subtract them, right? So let's see this operation, right? So I'm going to subtract corresponding elements. So I have negative 5 minus 5, then 4 minus negative 4, then negative 6 minus 6, and then 3 minus negative 3. So that means that this equals to negative 10. Then I got 0. Negative 6 minus 6 is negative 12. And then 3 plus 3 is 6. And remember that this right here becomes a plus and a plus. Let's see the next one. Again, let's start by defining my dimension. So this is a 1 and 2, right? So we have 2 rows, 3 columns. So this is a 2 by 3, and then the other one is a 2 by 3. So again, here we're just going to subtract 3 minus 0, negative 1 minus 0, negative 6 minus 2, minus negative 2, so negative 6 minus 2, then 6 minus 5, negative 1 minus 6, and negative 4 minus 6. So that means that this equals to 3, negative 1, negative 4, 1, negative 7, and negative 10. Okay, so number 3, again, it's a, let's start with the dimension. So it's a 1 by 4, and then this is a 1 by 4. So that means that this equals to 5 plus negative 4, 4 plus 0, 1 plus 6, and negative 6 plus negative 6. And this is 1, 4, 7, and then negative 12. Let's see the next one. So number 4, again, let's start by setting the dimension. So this is 2 by 2. This is a 4 by 1. So again, it has 1, 2, 3, 4, and just one column. So in this case, because my dimensions are not the same, that means that this is undefined. Let's see the next one, right? Again, we're going to start by doing this multiplication, because then after I do the multiplication, I'm going to figure out if it's undefined or not. So again, I'm multiplying the 2 times everything here. So 2 times 0 is 0. 2 times negative 2 is negative 4. 2 times negative 4 is negative 8. And 2 times 0 is 0. Minus, and then I have negative 4, negative 5, 5, negative 6. And then I'm going to subtract 0 minus negative 4. Oh, before we subtract, this is very important. I know that this is 2, but let's go back and check. This is a 2 by 2, and this is a 2 by 2. So that means that we can do the subtraction. 0 minus negative 4, then negative 4 minus 5, negative 8 minus negative 5, and then 0 minus negative 6. That means that this equals to 4, negative 9, negative 3, and then 6. See this one. Again, I'm going to start by multiplying. So I got a 10 and 2, and then plus negative 3 and 0. This is a 2 by 1, 2 by 1. So in this case, it's 10 plus negative 3, and then 2 plus 0. So that means that this equals 2, 7, and 2. And that's it for this video. May the 4th be with you.